All right, so we are finishing up the big chart for the unit circle, which means we have to know how to work with reciprocal functions. But before we do that, we need to go back and put all of this stuff together, okay? Now, when we were looking at the unit circle, and we were just reviewing a moment ago, we sat there and said, if I'm looking at the unit circle, my trig function, sine of theta, y was, the y coordinate is what gives us the sine function. We know cosine was x. And then we got the fact that our tangent was sine over cosine or y over x. We could use that to calculate tangent. Now, are there only 3 trig ratios? And the answer to that is what? No. We have 6. Now notice, strategically, we put them with their reciprocal functions, right? What do we know about the cosecant of theta? That's the same thing as 1 over what? Sine theta. So what's my answer going to be anytime I work with cosecant? It's going to be 1 over what? Y. Secant theta. That's a reciprocal function of cosine. So anytime by the way, there was a theta that's missing, so sorry. 1 over cosine theta, or 1 over x. So really, what am I just doing with my trig ratios? If I'm looking for cosecant, what do I just do? Flip-flop, right? My sine one. If I'm looking for secant, I just flip-flop my cosine. Now, as simple as that. Cotangent. What am I going to flip-flop? Right? If I'm doing this and I know it's reciprocal, isn't that the same thing as just x over what? Y, or cosine theta over sine theta. We just flip it. So when a lot of people all of a sudden start freaking out, they're like, I don't know what to do with cosecant. I don't know what to do with cosecant. Don't freak out. You just sit there and go, okay, which one of these is it related to? Like, I have to know sine goes with cosecant. I have to know that cosine, I want to know that cosine goes with secant, and I need to know that tangent goes with cotangent. Simple as that. Okay, now, some of you go, Ferguson, the unit circle is too messy. There's just too many numbers, too many crazy things on there. There has to be another way of working with it. Yeah, there is. How about just make a little chart and flat out memorize the chart for the first quadrant? Why don't we do that? So another way of working with this is going like, if I'm looking for these angles, I'm just going to put a theta there. We should be able to find these out. Now, here's where you have to be really careful. Sine is what coordinate again? Y. And cosine is x. Notice I didn't put it in order, cosine, sine. The reason why I put it in this order is to find tangent, what do? Sine over cosine, or y over what? There's a reason behind that. Okay? Now, if you're stuck, don't be afraid to glance at the first quadrant of your unit circle. But guys, what is the sine of 0 degrees? Think about where that's located on the unit circle. I'm at the sine of 0 degrees. What's that ordered pair right there? 1, 0. So what's the sine of 0 degrees? 0. Beautiful. What's the cosine of 0 degrees or 0 radians? All right, what's your tangent if it's sine over cosine? 0. Because 0 divided by 1 is what? 0. So you've got it. So and we also know that's going to be 0 radians. Okay, 30 degrees. What is your radian for 30 degrees? Just that needs to be flat out memorized by this point. Pi over what? 6. Awesome. Any reference angle that's going to be 30 is going to have radians that's over what? 6. Simple every time. Now, remember, that's going to be your point right here on the unit circle. What is the sine value of 30 degrees or pi over 6? Again, if you don't have it memorized, don't be afraid to look back at that unit circle real quick. What's the y? What's this one going to be? Yeah, because it's the short side. Yep, 1/2. Which means the other one's going to end up being what? √3 over 2. The nice thing is, you know it's 1/2 or it's root 3 over 2 most of the time. One of those two. Now, when you're doing the tangent for this, again, you could sit there and calculate it, but when you're doing all the work, that becomes root 3 over 3. So just another place where you can summarize it. All right, 45 degrees. What do we get? Pi over what? 4. Okay. What's so cool about the sine and cosine for 45? Exact same. And these are your root 2 over 2. Root 2 over 2. Okay. What's tangent going to be? Yeah, because everything divided by itself is 1. Root 2 over 2 divided by root 2 over 2. Numero or no? All right. 60 degrees. What do we get? Pi over 3. So anytime over 3, reference angle is going to be 60. What is the sign for that one? It's the root 3 over 2. Because think about it, it's way high up, right? So to get to that y, you had to go further. It's the root 3 over 2. We have our cosine of 30. They just flip-flop. And then, what is going to be our tangent value? This one's the root 3 one. Very good. 90 degrees. What is your sign? Now think about it. This is right here, 90 degrees. Okay, sine is which one? Is that what's the ordered pair? 0, 1. So what's sine? 1. What's cosine? What's 1 divided by 0? Unattainable. Oh, great, good. So it's undefined, right? So we actually have a value for that as undefined. And then on the bottom was us just using the phrase, all students take calculus, so we can know positive or negative. Now, this didn't happen in your class, but one person in the other class, literally all they gave me was positive or negative signs. They forgot to give me the values on their chart practice. So, it's good practice, but just make sure that you have those. Now, for you, if you are really overwhelmed by the unit circle, is this just a good summary spot? Is it? I mean, it could be where you do your memorizing. I've had people who memorize the chart, not the unit circle. Now let's go back to that awful big chart. All right, we should be able to fill everything out at this point. And I'm going to have a deep, dark confession with you. I don't memorize cosecant, secant, or cotangent. I just do the what thing with it. I just do it. Are you guys with me on that? I just do the flip. Why go through more pigmenting? All right, let's just go there. But you should be able to do that and fill it out based off of what you know. That's just remember when you're doing these, what they represent, and you're gonna be fine. Guys, if I have a sine of 0, what's my cosecant gonna be? Be careful. It's undefined. Very good. Someone goes, how do I know it's undefined? That's understood to be 0 over 1, right? So if you flip it over, that's 1 over what? 0. So it's going to be undefined. Excellent. Okay? So what's going to be the secant of 0 degrees or 0 radians? What's the reciprocal of 1? 1. 1 flipped over is 1. 1 over 1 is still 1 over 1. All right. Cotangent. Nope, it's 0 for tangent, so that's tangent. So this really is what? 1 over what? 0. So it's going to be what as well? Undefined. So it's understood to be 0 over 1. So when you do a reciprocal, it flips it over, it's undefined. Okay, now let's do the easy stuff. Guys, so we have the sine of pi over 6 or sine of 30 is 1/2. So what's going to be the cosecant of it? 2 over 1 or 2. I take both. Fair? I like taking it like the fraction like this because it really reminds you you're doing 1. Flipping it. Okay? Now, this is where I'm not as strict as as I am about rationalizing the denominator. But what should you know initially for the secant of 30 degrees or pi over 6? 2 over root what? In the heat of the moment on a chart quiz, do you think I'm okay with 2 over root 3? Now, if you're a brilliant student and you know how to rationalize quickly, it's 2 root 3 over 3. But would I be okay on a chart quiz with 2 over root 3? And the answer is yes. Do I deep down in my heart of hearts prefer rationalized? Yes. So rationalizing the denominator goes a long ways to keep the teacher happy. But if you're in the middle of calculating something in a problem, flip goes really fast. Do you guys agree? So, like, what are we going to do for the cotangent? 3 over root 3, which, by the way, guess what it rationalizes down to? Root 3. But again, doing the flip is okay. Now, here's what I want you guys to do. I want you to be able to go through here, and could you please quickly do the secant, cosecant, and cotangent of the next 3 rows. You do it with the person next to you or behind you, or next to you, or you can do it on your own. But please see if you can get these quickly, please. And honestly, I prefer rationalized, but like I said, in the heat of the moment, here we go. Totally. Okay. I just did 2 over 1 so you know what it's going to be. Okay. It's 2 and 2 over 1 are the exact same value. I prefer if they're rationalized, so I would put the flip over and then I would rationalize too, just because it helps you learn it quickly. But like I said, honestly, I don't memorize the last 3 columns. I just put them down and then rationalize on when I do it on my own. The only reason why I don't have to do as much as I'm teaching it so many times. Otherwise, I just always do the flip in my head and like, I'll rationalize off to the side and get it done. So yes, I prefer rationalized, but I always do it later. Okay, and remember which ones go together, guys. All right. I know I'm going really fast. If you did not rationalize, you're not the end of the world. I can give you the rationalized answers as we go. Okay. On the first one, guys, cosecant. Which one does it have a relationship with? Sine or cosine? Sine. And so if I do the flip over, it's going to be 2 over what? If you rationalize that, it's going to end up being root 2. If you rationalize it, just ends up being root 2. But here's the cool thing with that. I know secant goes with cosine. Is that still 2 over root 2? The most beautiful thing about 45 is just things repeat. It's so nice. Now, and what's the reciprocal of 1? 1. Sometimes easy is okay. Sometimes easy is okay. Okay. When we're looking at the next one, I have 60 degrees. What is the cosecant of 60 degrees? What's the initial flip? Yeah, that's just 2 over root 3. And again, I said that becomes up to 2 root 3 over 3. But if you know this, can you rationalize later on your own? Yeah. Exactly. Okay, when we're working on the next one, secant of this, what are we going to get for our value? 2, right? 2 over 1 or what? 2. Exactly. All right, next one. What's going to be the cotangent of 60? 1 over root 3. Can anyone guess what that rationalizes down to? Root 3 over 3. Have you noticed the root 3 and over 3 and the root 3s are just reciprocals of each other, just a quick flip? They're really nice. Okay, cosecant of 90. Which one do we look back at? sine was the reciprocal of 1. Now be careful. What is the secant of 90? Undefined, because that's 0 over 1, right? But if your tangent is undefined, what does your cotangent become?
0.
Because undefined was this, 1 over 0. So flipped over, it's what? 0 over 1. Okay, now, guys, we've just done the hard work. If you can do this, like again, the key thing for me is rationalizing in this big chart. I could care less about rationalizing the big chart. Just again, and answers like in the big chart. Just no flip. No flip. Are you guys with me on that? Able to do the flip. So, working with this. Yes, sir. Yes. So working with this, let's fill this rest of this chart out, knowing stuff that we do. Okay? So for instance, this was just our first quadrant. Okay? What quadrant is this one now? That's quadrant what? 2. Talk to me. Let's talk about signs. What is positive in the second quadrant? Sine. So do you agree with me? All of these are positive. Correct? Yeah. All right. Then, what does that mean for cosine and tangent? They're negative. Okay, now I want you to think carefully about this. What does that tell me about cosecant? Cosecant is just what flipped over? So if it's positive and I flip it over, it's still what? Positive. So notice the reciprocal functions match. It's reciprocal for sine. Guess what secant and cotangent are both going to be? Negative. And we know those are both negative. Okay, friends. Should I be able to pull in my information now to go with this? So think about this. 2 pi over 3. What's my reference angle? 60. So all I do is take this row, and where do I put it? Right there. It's exactly the same. The only thing that changes are my negative and positive signs. So then I just literally throw it in here. So I know this would be root 3 over 2. This one would end up being 1/2 root 3. Guys, should we put it in as the reciprocal or should we put it in rationalized form? What one? Rationalized? Okay. You just became favorite people because you did that. All right, and we go 2, and then we go what? Root 3 over 3. What would I do to get the 45 degree? Yeah, I just take this one, and I just copy it what? Copy it down, because the reference angle of 45 is exactly the numbers that I need. The positive negatives only change when you're in that next quadrant. So when we're working with that, we just plug it in real quick. We're going to have our root 2 over 2, root 2 over 2, 1. And then we end up having root 2, root 2, and 1. So again, keeping our positive and negatives. Can anyone guess what we're going to do for the next one? If I'm at 5 pi over 6, or 150 degrees, what's your reference angle? So notice, I just use what's at 30 degrees, and I write it down. Are you seeing how you don't need to memorize as many numbers as this chart makes it look like? You're just using the patterns to go with it. So I go over here at 30 degrees, so that would be a 1/2 here. I have a negative root 3 over 2, negative root 3 over 3, a positive 2, negative 2 root 3 over 2, and we're going to have a positive, or excuse me, a negative, make sure I use my right values here, negative root 3. Guys, what would I use for 180 degrees? 0. Now, the cool thing is, when I have like a negative undefined, is it just undefined, right? So when I look at this, I'm like, oh, at 180 degrees, my cosine is still 0. All right, what is going to be my cosine? Well, if it's positive here, it's what? Negative. What is going to be the value of tangent? We're not going to call it negative 0. It's just what? 0. Yeah, we just don't need to worry about that part. Okay. What's going to be your cosecant? Undefined. What is going to end up being your secant, which is just reciprocal of cosine? Your negative 1. And what's going to be our cotangent? It's still going to be what? Because it's flipped over, it's still undefined. All right. Are you seeing where these come from? Yes, sir.
On the negative 2 root 3 over 2, shouldn't that be negative 2 root 3 over 3?
Yes. I just wrote it wrong. You're correct. Thank you, Lincoln. Good save, bud. I appreciate it. Guys, when I'm talking, focus is always happening to me. Okay, talk to me. What do you know about quadrant 3? Yeah, tangent is the one that's positive. Okay, so everything else is what? So really tangent is positive. Guys, what does that mean over here? Cotangent has to be what? Positive. Everything else is negative. Negative, negative. Now, here's the annoying part, right? Until we get to our values. All right, can anyone tell me where I'm going to get my 7 pi over 6 or 210? Where am I going to get my information to fill it in from? From reference angle of what? 30. So I'm going to be using this one again. I am not memorizing the whole shebang for this. I'm just thinking of my first quadrant. Oh, what is sine of 30 degrees? Oh, that's going to be 1/2. So this is going to be a negative 1/2. What's the cosine of 30 degrees? Oh yeah, negative root 3 over 2. So just root 3 over 2. It's into the fourth quadrant, so it's negative. Oh yeah, tangent's positive. Oh, that's root 3 over 3. And then we do our flips. So we know that it's just going to be a negative 2. A negative 2 root 3. I'll get this right this time, I promise. Root over 3, right? 2 root 3 over 3. And then what is going to be our last one? Positive what? Root 3. Guys, could you fill in the rest? Now, notice, again, am I thinking, 210 degrees? No, what am I thinking? I'm thinking 30 degrees. I think reference angles. I don't think big numbers. I think about the easy ones I can go to. So when you have 5 pi over 4, the moment I see over the 4, I think what reference angle? 45. That's how quick and easy that is to put in. And so you just go root 2 over 2, root 2 over 2, positive what? 1. What are going to be these two values? Root 2 and root 2, and still positive what for cotangent? 1. And all I did was use my reference angle. Oops, let me do this here. For 45. What do I use for 240? What's my reference angle? 60. So I'm going to use everything from my 60. So you're not learning new stuff. You're just doing the repetition with this. So when we have that, we're going to have our, let me just put my stuff, negative root 3 over 2, negative 1/2, a positive root 3, because tangent's positive in the third quadrant. What do we have for our reciprocals? We got negative 2 root 3 over 3. Make sure that looks like a 3 represent. All right, and then we have a negative 2. Oh, a positive root 3 over 3. It just matches. Now, to be honest with you, for 90, 0, 90, 180, and 270, I really don't memorize this chart whatsoever. What I do personally on this is just go, where in the world is not what I want to do. go back? One more, right? There we go. What I do with it is I just memorize where those land on the unit circle, and then I just use quick calculations. So like at 270, this is my ordered pair. What's the ordered pair? 0 what? 0, -1. So when I go the sine of 270, I'm like, oh, that's just the y value. What's my cosine value? 0. And then I'm like, okay, tangent is sine over cosine. So -1 over 0, that gives me what? Undefined. Do you see how I don't take the time to I just picture the ordered pair. It's easier for me on that one. It's just my preference. But hey, what's the reciprocal? So if I have my cosecant, I know this is going to end up being -1. Our secant, this time it's going to be undefined. And then what do we get for our cotangent? It's what? 0. Are you seeing panic is not worth it, but seeing the patterns is. Let's get our last one. Okay, we're over here at quadrant 4. We're almost finished with anything new we need to learn for about the next 2 days. Think we can handle it? All right. So, quadrant 4. I go over here to 300 degrees. I go, oh, what's my reference angle? Oh, it's a 60, so we're doing everything here. But what do we know about sines in the 4th quadrant? Cosine is my positive one, correct? So we sit there and I know this is positive, this is positive. So if cosine's positive, what's my other one? The other ones are negative. Yeah, I go with you on that. But what would be the other positive reciprocal? Let me reword my question. Yeah, it's which one? No. If cosine is the one that is positive, it has to match its reciprocal. So it's going to be which one? Secant. Everything else would be your negatives. Unless, of course, it's defined or 0 or something like that, in that sense. Are you guys ready? Do you think we can crank these out pretty quickly? I have a feeling at this point you're like, Gregerson, I know the pattern, the torture. Okay, let's do it real quick. Guys, what is the sine of 300 degrees? It's going to be what? Negative what? Yep, -√3/2. But cosine of 300 degrees, or 5π/3, is a positive 1/2. And that is going to give us what value here? A -√3 if we calculated the tangent. And then we just do our reciprocals. So we get our negative, what do we get here on this one? 2√3/3. What do we get for our positive? 2 for secant. And what did we get for our cotangent? -√3/3. All right, guys. What do we use for 45? Right? 315 degrees, reference angle of 45. This one's the fun one. What do I put for sine and cosine? This makes life so much easier. √2/2. So I get -√2/2 for sine, a positive √2/2 for cosine, and for my lovely tangent, it becomes what though? A -1, because sine over cosine, negative divided by positive is negative. Now guys, doing your quick flips, what do we get here? A -√2, a positive √2, and still just a -1. Last but not least, we can do our 330 here, right, my friends, when we're working with it. And then you ask yourself, oh, what is the sine of 330 degrees? Oh, that's the same thing as the sine of 30 degrees, which is going to end up being what value? 1/2, right? So this is just a -1/2. Oh, what makes cosine then? √3/2. So positive √3/2. Oh, what is going to be my tangent for this? -√3 what? 3. Then we do our reciprocal flips. 2√3/3, and then this would end up being a negative. Oops, wrong one. Let's see if I can get it. √3. Make sure I put the right thing down. Okay, for the last one, go Go back to what you already know. Where does 2 pi land? On the positive x-axis, right? So that's just 1. Make sure I write what I want to write here. 1, 0. Guys, what's the tangent? Not, excuse me, tangent. What is the sine of 2 pi? 0. So I'm going to get rid of that negative, and I'm just going to put a 0 down. What is the cosine? What is going to be the tangent if it's sine over cosine? 0 divided by 1. 0. Okay, this should be easy. If I'm using reciprocals, what do we got? Cosecant is going to be undefined. Secant, which is reciprocal of cosine, is 1. And then our cotangent is also going to be what? Undefined. All right. We need to practice, and we need to practice a lot. What do you guys think? All right. Here's what I want you to do. I think we might need to do some whiteboard review. All right. But how about if we fill out this keys to memorizing first, and then you can kind of use it while we're doing the review. Does that kind of make sense? Let's try to do that. So let's go back on the handout that you grabbed on the way in. I think I might have on it here. I'm gonna do the keys. I gotta find out where I put the keys in memorizing it. Don't know if I put it there. Yep, the tips for memorizing. Don't know if I put the blank one on it. Yes. Is this one filled in? I hope not. That's not unit circle. Where's my text? There it is. Alright. You guys got that out? Okay. Let's see if we can simplify that big ugly chart and get it to look pretty. Here's Mrs. Gregerson's way of doing this. This is a personal one. I memorize this quadrant and that's it. I do not sit there and let my little head worry about what's 240 degrees. I just don't. Because I know all I have to do is change negative signs. That whole big chart we just filled out, was it just positive and negative sign differences? That's it. So let's make sure that we plug it in. All right, so looking at this chart, 0 degrees is also 0 radians. Would you guys agree? What's the next angle going up? 30. What is that in radians? That's your pi over 6. So anytime I see radians over 6, if it's simplified, that is, I know I'm working with a reference angle of 30. Okay, what's our next one going up? 45, correct? So this is 45. What's that in radians at this point? Oh, you guys are catching up. This is beautiful. Okay, next angle. 60. And what is my radians for that? Pi over 3. And then we go 90, and it's pi over 2. Okay, awesome. Now, let's go ahead and let's plug in our quadrant. Let's just put it in. Let's put in our coordinates for each one of those ordered pairs. Which, okay, let's see where they're going from. Lincoln, where did those ordered pairs come from? Very good. The reference triangles for 30, 60, 90, 45, 45, 90, or 60, 30, 90. Correct? So good. You're right where you need to go. I think you got where it's going now. Great. So guys, however, this should be really easy. What's this ordered pair right here at 0 degrees or 0 radians? 1, 0. Because I have a distance of 1 over 1, 0. Okay, we're going to do tangent lines. We're just going to put these in. Now, I want you to think about this if you're looking at the reference triangle. Friends, you don't have a lot of choices. You have root 3 over 2, 1/2, or root 2 over 2. When you're looking at it, and I was just looking at my reference triangle right here, what's bigger, the x value or the y value? X. So what's going to go in for this one? Root 3 over 2. What's this one over here? What's going to be my sine value? 1/2. I love pi over 4. Because does anything change? No, it's the reciprocal. I wouldn't say reciprocal. It's just the same because it's an isosceles right triangle, so sine and cosine are the same. What are my two values for that? root 2 over 2, root 2 over 2. Beautiful. Now, thinking about reference triangles again. I'm looking here. That would be my reference triangle. Guys, what's bigger? The vertical or the horizontal part of my triangle? The vertical. So guess where the root 3 over 2 goes? Not in highlighted though. There we go. Root 3 over 2. That means this is going to be the short one. Alright. Please tell me what would be my autre pair at 90 degrees? 0, 1. Okay, guys, this is where you now can just quickly calculate tangent for all of this. So let's let tangent equal green. Tangent theta is equals my green value right here. How do we calculate tangent? Sine over what? Cosine, or y over, okay, guys, tangent of 0 radians. If I go y over x, what's 0 divided by 1? 0. There's your tangent. What's my cotangent for that now? It's what? Say it louder. Undefined, because it's just what? It's just what? You see how I don't worry about the extra 3, the cosecant, secant, or cotangent? I just go, oh, I flip. No big deal. Okay, guys, help me on the next one. And if you need to calculate it for a little while, that's fine. But what should be the tangent of 30 degrees if I go sine over cosine? Yeah, this one ends up being root 3 over 3. How did I get that? I literally went 1/2 divided by root 3 over 2, and I calculated that. So I just did my math. But it's just root 3 over 3. Friends, what's your tangent if I'm calculating it? Green box here. Sine over cosine. Root 2 over 2 divided by root 2 over 2. What? How am I going to find this one over here? Well, I'm going to sit there and go root 3 over 2 divided by 1/2. Root 3 over 2 is the same thing as times 2 over 1. Oh, wait, what does my answer become? Root 3. And then what is our tangent value? If we do this one, if I go sine over cosine, 1 divided by 0, which is what? Undefined. People, that's all you have to memorize. Because reciprocals, you're just going to always do what? Flip and then rationalize your denominators. Simple as that. Now, what about the other quadrants? Well, the other quadrants, should we know positive and negatives, right? And so we let the other quadrants be working with this. So what fun, cutesy, little saying do we use so we remember what's positive or negative? Yep, all students take calculus. Now, notice I only give you the 3 basic reciprocals, but should I know what the other values are as well for positive and negative? But with this one, all means they are what? All positive. Which also means cosecant, secant, and cotangent are also positive. All right, when we say students, what does that represent? Sine, so that's positive, and these 2 are negative. Which also means then, my friends, that your cosecant is positive, but our secant, you can think of it like this, is going to be negative. This would be positive, and my cotangent is also negative. So reciprocal functions have the same positive and negative signs. Does that make sense? All right, sine. Next one. This is first quadrant. This is second. What about third quadrant? The tangent is positive, but the other 2 are what? Which means cosecant and secant are both what values? Negative. And then our last one is what? Cosine. Sine and tangent are negative. So what does that make cosecant? Is cosecant going to be positive or negative? It's negative because it goes with sine. What about secant? Positive. What about tangent? Negative. Does that make sense? No? Yeah, are we getting a little bit there? Now, okay. Now, some people hate the unit circle, so guess what they use? Chart. Guess what? Do you think I really care which one? No. I really, really don't care which one you have. Just so you flat out know. Pick what works for your brain cells, because you're mature enough at this point to know what works. Guess what? For some people, this doesn't work. So they literally make flashcards like this. One side, they'll just go like this. And you notice they don't do it in degrees because degrees are easy. So they'll be like, oh, sine of pi over 3. What are you going to put on the back side for sine pi over 3? By the way, what degrees is this? So what's the sine of 60? That would be root 3 over 2. Make flashcards. The good old-fashioned flashcard. Make a Quizlet. I don't think that's cool anymore, but you know, you could do something like that. But you can totally do those. Be able to fill this out. So, also, I would, if I had a chart like this, I would just make sure I had my radians over the top of it, so I remember how to do reference angles when we're doing it. You could fill out the chart, and we just did that earlier. Guys, I should be able to ask you, and you should be able to respond. Sine of 0 degrees. Oh, that's 0. Cosine of 0 degrees. That's a positive 1. The tangent of 0 degrees, because that's sine divided by cosine, is what? 0. Oh, then I turn around and just go up to the next value in the unit circle. Oh, the sine of 30 degrees. Oh, that's just going to end up being 1/2. What's cosine? Root 3 over 2. What's my tangent? Root 3 over 3. You just memorize it. Whatever works for you to do. Guys, some people are very visual. Every time I ever give them a unit circle, the first thing they do is they draw the unit circle. Some people, they're like Gregerson, confusion. They draw a chart. Sometimes I put a chart. Sometimes I put the unit circle. I don't grade those, but I just give them as a visual aid for people who do this. All right, guys, I bet you know this one right now. What's sine of 45? What's cosine? What's tangent? So you at least got, 45 down, friends. Good job. All right. Sine of 60. That's root 3 over 2. What's cosine then? Flips around, and then you get root 3. Sine at 90. Nope, careful. Sine of 90. 1. What's cosine? Tangent. Thank you. So, simple things to do. No reference angles, or remember how to recognize or find them. Anytime you see over 4, if it's reduced, remember, over 4, what's your reference angle? Pi over 6, what's your reference angle? Pi over 3, what's your reference angle? All right? You should be able to, pi over 2. And so we get, for this one, 90. Okay, if I can write what it actually you guys said. All right, wonderful. Now, you need to be able to do, without converting to radians to degrees, be able to figure out reference angle and measurement angle with no problem. So we're going to do a little bit here to figure this out. I'm going to pull one out, and I want to see if you guys can tell me without having to do that old process, which, by the way, you still have to know how to do. What if I gave you something like this? 5 pi over 6. Don't tell me angle measurement yet. Right now, just tell me, what's my reference angle? 30. Now, tell me that in degrees. What does that measure in degrees without having to calculate real hard? How did you get that? Yeah, because my reference angle, what quadrant am I in? Second quadrant. And reference angles always go from the axis, right? So you just go, what's 180 minus 30? 150. A lot easier than having to plug in a value and reduce fractions, right? Guys, what's this one going to be? 4 pi over 3. The reference angle, you got, great, 60. What's the angle? Because I'm in what quadrant? I'm in the third quadrant, so I had to add 60 to the 180 to get there. That's 240 degrees. You've just learned that to where to go with them very quickly when you're working with it. All right, guys, how about this one? 7 pi over 4. Without telling me the reference angle, what's the measure? What's that in degree? 315, because what's your reference angle? And 360 minus 45, 3 what? 315. You just get good at it. Plus, we always use the fun little sayings, like this is just under what number? 2, so we know it's in the fourth quadrant. This is just over the number what? 1, third quadrant. This is just under the number 1, second quadrant. So you can sit there, and that will also tell you positive or negative signs, correct? Also, remember to use your reciprocals to find cosecant, secant, and cotangent. Don't make this hard. All right, are you guys ready to do some practice? I think we should do some whiteboard practice because you guys can do the chart without me. So let's see if we can go fairly quickly with this. I have, yes. And to be honest with you, tissues erase better than anything else I've got. So if you can take your tissue, then your printer's not there, and pass back. Okay, well, it's going to happen eventually. It's a new box. Sorry. Okay, take the tissue, pass back. Okay, we need 5 here. Are you going to use it in the wrong 5? Or paper. You guys make sure everyone has a marker, please. Do not give the erasers. The eraser's trash. I've learned my lesson after last year. Yeah. Make it a little more sensitive.
Yeah.
I hope.
Yeah.
Really fast. I think that might be an extra one. Grace just keep it moving. Just longer, that's all about it. Let's show you that. Alright. Do we need more markers? Did everyone get a marker over there too? Okay, perfect. Did you get markers? Gotta make sure you got markers, guys. Okay. Let's do, and I'm gonna do some harder ones, but we're gonna do some warm-ups to see if you got this. Tomorrow, you're going to be so sick and tired of whiteboard practice. So, if you are struggling, here's what you may have beside you. You may have your unit circle beside you, okay? Some of you might want to push yourself and go, I don't need to look at this. I'm brilliant, you know. Great, I'm good with brilliant. I'll take it. But if you're struggling, use the unit circle to help you out. Are you guys ready to try these? Okay. We're starting easy. We're going to do degrees and we're going to do radians. Are you guys with me on this? Easy, easy start. Sine of 5 pi over 4. Fine for me, the sine of 5 pi over 4. If you need to write off to the side, quadrant, reference angle, all that type of stuff, go for it. I'll talk about it after I give you a chance to get it. No, I didn't ask for the degrees. I asked for the what? Sine of 5 pi over 4. Yes. 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 No. 1. Yes. Yes. Careful. I'm asking for the sun. Yes. Yes. Could you make that readable so I can see it? I appreciate that. Almost. What quadrant are you in? That's so much better. Yes. 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 So my reference angle is 45. Great. What's the sine of 45 degrees? Root 2 over 2. What's my problem, though? Am I in the first quadrant? No. What quadrant are we in? We're in, not in second. We're in our what? Third quadrant. Which means all students, what? Take tangent's positive, but that makes my sine what? Negative. So negative root 2 over 2. All right? That kind of gives us a little warm up on that one. Okay. What about the following? Let's go the cosine of 135 degrees. Do you love how I'm just flipping between the two? Cosine of 135 degrees. Almost. Nope. Yes. Okay, that's the angle. 3 pi over 4 is the angle. I'm actually asking for the cosine. Close. Close. Yes. Close. Guys, you're doing good with the reference angle, but you're not doing good with the quadrant it's in. So let's make sure we got that. Yes, 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 yes. Good saying. Yes, it's amazing how you got that. Yeah. Beautiful. Yes. Yes. All right. Yes. All right. When you look at this, what's your reference angle still? Do you notice that it's actually faster with radians? Because do you actually have to calculate the reference angle? If you know degrees, you have to calculate the reference angle. This is just go reference angle, 45 degrees. Great. What quadrant are you in? Second. So what do you know about cosine in the second quadrant? It's negative because it's all students. Students is sine. That's positive, which means my cosine is now negative. So this would be negative, and then, hey, cosine of 45 degrees, root 2 over what? Now, some of you who gave me the answer of a positive root 2 over 2. Every question on the unit circle quiz that we do on Monday is worth 2 points for the sine and for the ratio. Okay, for the sine and for the ratio. So if it's positive, that counts as a point. Or negative, it counts as a point. And then the actual number. But please remember, if you see this, you're looking for the ratio. You're looking for the answer. Okay, now I'm going to add, let's do another one here. Let's do the following. The tangent of 2 pi thirds. And then I'm going to start throwing in the reciprocals as well. The tangent of 2 pi thirds. Or you want me to look? Are you fine? You got it, right? You're getting it? I'm looking? No, be careful. What's your reference angle? Yes. Almost. Almost. Yes, yes, yes. Almost. Yes. What quadrant are you in? Yes. Oh, yes. 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 So you calculated it. You got it right then, right? Like, you have to do that. Eventually you want to have it memorized, but you have to calculate it. Fine. Fine. Good. Yes. Fine. That's not so bad. Yes. Good. Yes. Guys, talk to me. What quadrant are you in? Which right away means positive or negative for tangent? It's negative. So right away, I actually put my negatives down first or positives down first. What is your reference angle? Your reference angle is 60. So then you just go, tangent of 60 is root 3. Some of you calculated it. That's totally fine, because is that still a valid way, as long as you have your sine and cosine? Perfect way of doing this. Okay, now let's switch this up a notch. What's the cotangent of 2 pi over 3? There's a reason why I haven't erased my answer. Yes, rationalize. Just keep going. Just get in the habit of rationalizing. It'll make your life easier. Like do that and then rationalize. Good. You learn the pattern so fast. Okay. Okay, then yes. Yes. Almost. What quadrant are you in? That's what you just have. That's what why you need this quadrant is just a positive. Yes. 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 No, but you're thinking kind of stuff right. Yes. Yes. Just rationalize it out there. You have a very happy teacher. That's the only thing you have to do. Yes. Because it's in the quadrant. Okay, but you're on that track. Guys, wonderful. Okay, I just need you to hear me on this. Wonderful. Overall, not bad for the first time doing it with a reciprocal function. You are going to have to know these. But, guys, cotangent of 2 pi over 3 is the same thing as 1 over the tangent of 2 pi over 3. Correct? It's the reciprocal of this. So those of you who did this, were you thinking correctly? Yes or no? Yeah, just rationalize it. That doesn't take that long to do. This is negative root 3 over 3. But it's just the reciprocal of tangent. So really, you have to think about what this value is. What's the tangent of 2 pi over 3? Okay, let's do some more. I feel like we're warming up a little bit. Okay. What is going to be, like this one. Let's do the cosine of, let's just go 60 degrees. What's the cosine of 60 degrees? Nope. Cosine. You're thinking like you're going to tangent world, Paul. We're not going to tangent world yet. All right. Yes. Yes. No for sine. Yes. 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 Nice work. Good job, all six. Good job. All right. I said yes to you, right? Okay, good. Yes. No. Yes. Yes. Okay. Guys, do I really have to worry about reference angle on this one? And do I have to really worry about what quadrant I'm in? What quadrant are you in? So everything's what? Positive. But you have to have memorized the cosine of 60 degrees, which is just 1/2. All right, now let's try something. The secant of 60 degrees. Yes. No, that number's not coming to you on this one. All right. Yes. Guys, I gave this away to you. What are the reciprocal functions? Cosine and what? Secant. Secant is always just 1 over the cosine, which means flip it. It's just 2. It's in the first quadrant. If it's in the first quadrant, always positive. No matter what values in the first quadrant, everything is what? All 6. All right, let's do another one. Are you guys seeing that? Some of you just have to sit down, crank out, and memorize that first quadrant stuff. It really will help you. Okay, let's try the following. We're going to go back 3 radians. Let's do tangent of, let's go 11 pi over 6. Tangent of 11 pi over 6. Big reference angle, big quadrant, you know the positive or negative. Yes. 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 That's it for you, right? Yeah. Yes. That was just me not being careful. Yes. Almost. Don't you think that thing? You know, negative sides come back to get you. Yes. Is it positive or negative? Serious.
We said almost.
Guys, with this one, what quadrant are you in? All right, so is tangent positive or negative in the last one? Negative, because cosine and secant are going to be the positive ones. So this is negative. So before anything else, you should have been negative down. All right, what's your reference angle? 30. And then you go, okay, tangent of 30. Notice I just go straight to that. Tangent of 30 is root 3 over 3. All right, you guys know what I'm going to ask you next. I'm positive you know where I'm going. You should be able to tell me this without having to think too hard about it. What should you know without having to actually know a number? Once you get it, you're going to start seeing a pattern, and then you don't want to. The memorization is easy. Yep. Guys, right now, I'm loving saying yes more than saying no. So let's keep it up. And just let's see right? Just finish with the rationalizing. Just rationalize it, otherwise you'd be good. Yes. Yes. No. Yes. 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 Guys, if tangent's negative, what does cotangent have to be?
Negative.
Negative, and you're right. Those of you who sit there and said this, beautiful. Rationalize your denominator. Let me do a quick review how to do that. That means you multiply the numerator and the denominator by root 3 over 3. Root 3, excuse me. And you get negative root 3 over 3, which simplifies down to be what? Notice the flips between the two. You get them down pretty quickly after a while. Okay, now I'm just going to go cold turkey. Let's do this one. Are you guys ready? I want the cosecant of 150 degrees. Might take a little more thought, but I know you guys can do it. No. Oh wait, I might have said it. Yeah, you guys are thinking the wrong one, so no. No. Actually, no, wait, I said that wrong. Yes. Yes. I had to think wrong. I was wrong. Hello. I didn't go the right way. You were right. I think you were right, Paul. What did you have for your first one? Just write it down. You remember? Sure. I think I told you wrong after I said it. Yes. 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 And that's true. Oh, almost. Yes. All right. Nope. On this one. Yes. Yes. No. Almost. Yes. Almost. Guys, let's go with this one. Cosecant goes with which value? It's 1 over sine. Okay? So, really, this is 1 over the sine of 150 degrees. Sine is positive or negative in the second quadrant? Positive. So right away we know this is going to be positive, right? But what is the value of the sine of 150? This is when I was calculating it wrong in my head and you guys caught me right away. It's 1/2, right? Which is a reciprocal is 2. And it's positive. So those of you who said negative, just go, what is the quadrant you're going in? All right, let's do another one because it's good for me. Let's get cotangent of 7 pi over 4. Cotangent of 7 pi over 4. Yes. 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 Grace, that's a yes. 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 No, Paul, think about what tangent value is. Think tangent value. Yes. 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 No. What's your reference angle on that one, Carlton? Yes. Okay, so then why are you using 30s and 60s stuff? Yeah, you gotta use what? Alright, yes. 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 He moved his head right when I was looking at it. Yes. Yes. Guys, cotangent, great, is a reciprocal of what? Tangent. Would you guys agree? So we know it's going to be a flip. What is your reference angle for that? 45. So my reference angle is 45. I know I'm working with tangent, with cotangent, but I'm also in what quadrant? Is tangent positive or negative in the fourth quadrant? Negative, because cosine is the positive one, right? So if tangent is negative, cotangent is negative. But what's the value for that? Well, what is the tangent of any 45-degree angle or over 4 angle going to be? 1, right? So that just ends up being a -1. Please remember, anything that's over 4, anything that has a reference angle of 45, sine and cosine are just root 2 over 2, and your tangent is just what? 1. Okay? Let's do another. You see why we're practicing this? You have to. If you don't take the time to memorize it and memorize it correctly, that quiz grade could just sink your grade even. You're like, I love you all, but some of you are borderline grades right now. It could really pull you down. Or it could really pull you up pretty quickly. But you have to take the time just to learn it. All right, let's do an easy one. Let's do an easy one. How about the tangent of, no, let's not do tangent. Let's do secant. How about the secant of 5 pi, do I do this one? Yeah, 5 pi over 4. Okay, that's not easy. I just totally lied. But secant of 5 pi over 4. I was going to go easy and then I went hard. Sorry. Yeah, just rationalize. Otherwise it's perfect. Rationalize, you got it. Think about what's your reference angle on that one? Yes. Just rationalize and you got it. Yes. Yes. I'm so proud of you guys for rationalizing denominators. It's like you've come so far from geometry days. So beautiful. Yes, you got it, by the way. Yeah, just take the 2,000. You got it, Paul. Yes. 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 Almost a yes. Now it's a yes. Yes. Okay, beautiful. Guys, when you work with this one, what's your reference angle? So my reference angle is going to be 45. But we know secant is the same thing as 1 over what? Cosine. So when you're thinking about that, that's 1 over root 2 over 2. But in this one, is it positive or negative? Negative, correct? Because we're in the third quadrant. Cosine is negative. So when you flip it over, this is what you get. Oh, what was my comment for those of you who left that way? Just do what? Rationalize. If you do that, you get -2 root 2 all over 2, which is just a negative root. Yep. You guys with me on that? So a lot of you just need to rationalize this.
Do we have to show the unrationalized form, or?
If you have it memorized, I don't care. Like, but I don't memorize, I never personally memorize the secant, cotangent, or cosecant. I just always write it down and then flip. Just because I don't want, I think my brain has a limited capacity at my age. This is the point I've taught so many times. It's in there, but it's not because I'm brilliant at it. Let me tell you. All right. Yes, ma'am. Yeah. All right. Are you guys ready for another one? Should we go easy or hard? Hard. Easy. Wow. I'm feeling like degrees or radians. All right. You guys want degrees? Okay. let's see if you can do this one. Cosine of 300 degrees. Did I do that one already? Did I do that one already? I feel like I did. But oh well, just do it anyway, because you're going to see it again in your life, so just as well. All right. Yes, 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 yes. Almost. You have a thing against negative signs and positive signs in the right quadrants, but now nope. Both of them. You're flipping around your 30 and 60. All right. Yes, yes, yes. No. Close, but no. Yes. The positive is correct. I'll give you that. Okay. All right. What's my name? Is that or is that just a straight line? Yes. 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 That one's where you just have to get it down. That's hard. Yeah. Yes. Yes. Guys, to be honest, I know it's hard, but cosine we always know is going to be what in the fourth quadrant? Positive. What's your reference angle? 60. So the cosine of 60 degrees is 1/2. So it's a positive 1/2. Now, what's easy to do is flip-flopping your 30 and your 60 around because they're the exact same fractions, just in the x and y switch, right? This is when I visualize what I have, and it's the only way that I do it. If I'm looking at my reference triangle, it would literally look like this on the xy plane. Cosine's the short side. It's the 1/2 side. It's because it's the x side. But that's how I keep them straight. But, you know, it's really kind of up to you guys on this one. Okay. Let's do another one. Let's do one in... Let's do one in degrees. Have I done this one yet? 7 pi over 4 pi. Is it sine of 4 pi over 3? Did I do that one yet? Even if I did, I guess it's good review. So sine of 4 pi over 3. Right away, if nothing else, you should be able to tell me if it's positive or negative. Our pattern's starting to come?
Yeah.
Good. For some of you, I know what you're doing on Sunday night. Studying. Good. Good. Yes. It's supposed to be what? Yes.
I can't see that. Yeah. I had to.
Yeah, there is no way I would have seen that one. But now I agree with you. Yes. Okay. Beautiful. Guys, that one was actually pretty solid. I think I said almost all guesses. Great job. That's just negative root 3 over what? 2. All right. Are we at a better space? Okay, let me show what homework looks like. It's going to look really familiar to you. It is just like your last homework. The only difference is you have what? The other 3 of them in. Here's your goal. Everyone ready for this? Here's your goal. Your goal is to try to do it from memory. Try to do it from memory. Or just with your first quadrant next to you. Are you guys with me on that? Try to do it with just either your first quadrant next to you or from memory. But how can you check this? Use your unit circle, or could you use that nasty chart we just made? Yeah, you could use the chart too. So you still should be able to correct this. But quite frankly, you guys were getting it at the end. So I'm not as worried as I was at the start of class. I feel like we're a little bit better at the end.